Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to Lesson 7, Solve for Unknown Angles, Transversals. Alright, a transversal. Alrighty, so classwork opening exercise. Use the diagram at the right to determine X and Y. Line AB and line CD are straight lines, so I drew it in red. AB's in red, CD's in blue. So those are the two lines that go on forever in both directions. So this is an opening exercise. It's an exercise, so please pause the video, try it on your own, and come back and see how you did. Alrighty, here we go. So the first thing I need to do is determine which portions are going to be beneficial for me to use in the solving of this. And what I mean is if I look at, let's say I focus on this blue line and I see angle 1 here and angle 2 here and angle 3 here, I have a y, I have 90 degrees, I have an x. And I say to myself, can I solve an equation with two variables? And the answer is yes, but there's infinite solutions, so let's find something else. Alright, so let's not do that. Okay, so then I focus on the red line. And I have angle 1 here, angle 2 here, and angle 3 here. Or I could have done 1, 2, 3 here, but this is a y, this is an x, and this is an unknown. So I can't do below the red line. So if I look above the red line, then I have 90 degrees, an x, and an x. So that's where we're going to start. So I'm going to say 2x minus 8 plus x plus 8 plus 90 equals 180 degrees. Now there is a shortcut here, but we're focusing on adjacent angles on a line. So that's why I'm adding this up and setting it equal to 180. Some of you may be privy to the fact that if there's 90 degrees here, then these two have to be the other 90. So you take this plus this equals to 90, and that would eliminate this step here. But I'm just going to show it just because of the theorems we're using. And I'm going to do two steps here at once. I'm going to subtract 90 from both sides. And no, I'm not. I disagree with that. I don't want to do more steps than I have to. Let's combine like terms. 2x plus x is 3x. Negative 8 plus 8 goes away. Plus 90 equals 180 degrees. Actually, I could have done what I was doing, but that's okay. So then I subtract 90 from both sides. And I get 3x equals 90 degrees. Divide by 3, and x equals 90 divided by 3 is 30. So x is 30. So if x is 30, this is 38 degrees. If x is 30, this is 30 times 2, which is 60, minus 8, which is 52 degrees. 52 plus 38 is 90. 90 plus 90 is 180. Okay, so now let me just get rid of these 1s, 2s, and 3s. All right, and now we have to find y. Well, I still don't know what this is, so I'm going to leave that alone. I'm going to come over here, and I have a y, and I have a 90, and I have a 38, and that's what I'm going to use. So y plus 90 plus 38 equals 180. Combine like terms, y plus 128 equals 180. Subtract 128 from both sides, and that leaves me with y equals 10 minus 8 is 2, 7 minus 2 is 5. So y is 52. Name a pair of vertical angles. Okay, so I have this angle that's formed by the red and blue line. I have this angle that's formed by the red and blue line. And I can't see, that's O, I guess. All right, so I need to know what my vertices are. So if I say angle AOC and angle DOB or BOD, either way, angle BOD. So those are the two angles that are vertical. Are there any others? And the answer is no, because F is a segment that doesn't go beyond. EO is a segment that doesn't go beyond. So in order to have vertical angles, you have two lines that intersect. Okay, now it says find the measure of angle BOF, which is BOF, which is right here. Okay, so let me get this out of the way. And in doing this, I could call this Y or X, doesn't matter. Let's just leave that for now. I'm not going to name it. It's just going to be angle BOF. So I'm going to say the measure of angle BOF plus 52. Okay, so I'm looking on this side of the blue line, plus 4x plus 24, or minus 24, equals 180. I know what x is though, it's 30. So I'm going to put 30 in right here. So that's going to give me the measure of angle BOF plus 52 plus 4 times 30 is 120. 120 minus 24 is 96. Oops, 96 equals 180 degrees. Combine like terms. The measure of angle BOF plus 96 plus 2 is 8. 9 plus 5 is 14 equals 180 degrees. Subtract 148 and we are done. So the measure of angle BOF equals 10 minus 8, 2, 7 minus 4, 3, 32. So I'd say the measure of angle BOF equals 32 degrees. Okay, I always like to check my work, so I'm going to get this question mark out of here. I'm going to put this 32 degrees here, and I knew that 4x minus 24 is 120 minus 24, which is right here. We calculated it right here, and that is 96 degrees. 6 plus 2 is 8, plus 2 is 10, so we get a 0 carrying a 1. 9 plus 1 is 10, 13, and 5 is 18, and it checks. All right, discussion. Given line AB, right here, so let me label that. Okay, now they're calling them lines here, but in the diagram they're segments. See the dots at the end? But I changed that. So given line AB in red and line CD in purple in a plane, in the diagram here, a third line EF is called a transversal if I made this as the blue line here. Okay, a transversal if it intersects line AB at a single point and intersects line CD at a single but different point. And what they mean by single or different point is I could have a line AB like this and a line CD that intersects, and then this is coming through. That would not be a transversal because it's not crossing the two lines at a different point. Capiche? Okay, line AB and line CD are parallel. Okay, so if I want to label that as parallel, what color could I use? I'll just use black. Let me get my pen. Okay, so if I line that, they already did. This little mark right here is telling us they're parallel, so never mind. Okay. Okay, so it says line AB and line CD are parallel if and only if the following types of angle pairs are congruent or supplementary. Corresponding angles are equal in measure. Alternate interior angles are equal in measure. Same side interior angles are equal in measure. Okay, so it doesn't ask here, but I believe what they're saying is what angles are corresponding. Okay, so let's label this puppy up. All right, so corresponding, what does that mean? Correspond. All right, so this is my transversal. Corresponding angles are on the same side of a transversal and have the same angle measure. So if one is above a parallel line, the other one is above. So if I chose this one, then it's this one. The two acutes on the left side of EF. So angle A, corresponding angle A and corresponding angle E, or there's more. I could have chosen angle D, angle H. There's more. I'm not going to write all of these, but I hope you get the idea now. Angle B and angle F, angle C and angle G. So as long as they're on the same side of the transversal and on the below on both parallel lines or above on both parallel lines. Okay? So A's above, E's above, C's below, G's below. They're on the left side of the blue line, they correspond. On the right side, these four are our choices. If I choose B, it's above AB, so I have to choose F because it's above CD. If I choose D, it's below AB, so I have to choose H because it's below CD. So those are all the corresponding angles, and they're equal in measure. Alternate interior angles are equal in measure. Okay, this is my interior. The interior is in between the parallel lines. This is my exterior. All of this up here and all of this down here is also exterior. Got it? Interiors in between the parallel lines, exteriors above the upper parallel line, and the other exterior is below the bottom parallel line. So, alternate interior. So first of all, I'm focusing on these four. And alternate means if I'm picking one angle on one side, I have to do the alternate side, and it's got to be equal, so it's down here. Obtuse, obtuse. Acute, acute. So alternate interior angles that are equal in measure are angle C and angle F. Or I could have chosen D and E. Okay? Actually, I should be using angle measures here. Angle D, angle E, angle C, angle F, angle A, angle E, angle D, angle H. Get it? Same side interior. Alrighty, so we're still in the interior. So I don't care about AB. I don't care about GH. They are exterior. So, same side interior, well, angle C. If I choose angle C, which other angle's on the same side of the transversal? And it's angle E. Or I could have been on the other side and said angle D and angle F. All right. Okay, page 2 brings us to an example. All righty, examples. So here is a parallel line. These are parallel lines because of these arrows. This is a transversal because it crosses both line segments at different points. It has to be different points because they don't intersect. Okay, so what they're asking is, what's the measure of angle A? Well, this angle here and this angle here are on the right or top side of the transversal, same side, but they're not interior angles. One's exterior, the other one's interior, but they're congruent because they're corresponding angles. So the measure of angle A is 48 degrees. Okay, the measure of angle B. Again, parallel lines with a transversal. We're on the north side of the parallel lines. We're on the same side. They're interior. Same side interior are supplementary. Did I say that on the last page? I don't think I did, but they are. So, let's say it here. Corresponding angles are congruent. Okay? And if I go back and look at the last page, same side interior, one's acute, one's obtuse. Same side interior are supplementary. Okay, same side interior angles are supplementary. So in other words, if I just take 180 minus 48, I will get 10 minus 8 is 2, 7 minus 4 is 3, bring down the 1. Measure of angle B is 132 degrees. Okay. Alternate interior angles. Alternate interior angles are, okay, acute, acute. Well, guess what? They're congruent. So this is an alternate interior angle. This is an alternate interior angle. We are in between the parallel lines. We are opposite sides. Opposite interior are called alternate interior angles. They are congruent, so the measure of angle C is 48 degrees. All right. This is the exterior, this is the interior, this is the exterior. We haven't done this one yet. D is here. This one is over here. They're alternate exterior angles. Okay, obtuse, obtuse. They're both obtuse, they're congruent. And the measure of angle D is 48 degrees. So let me say something about this. If we have diagrams with two parallel lines and a transversal, either the angles are congruent or they're supplementary. Period, the end. Okay, so if they're both acute, they're congruent because two angles less than 90 can't add up to 180. If they're both obtuse, they're congruent because two obtuse angles cannot add up to 180. 101 plus 101 is 202. It can never equal 180. 91 plus 91 is 182. Okay? Number 5. And blank is sometimes useful when solving for unknown angles. Okay, this is a new term, and it's called auxiliary line. Auxiliary. Okay. A-U-X-I-L-I-A-R-Y. Auxiliary line. Auxiliary line is sometimes useful when solving for unknown angles, and that is our dashed line here. Okay, in this figure we can use the auxiliary line, oh, they gave the answer right there by the way, to find the measure of angle E. So here's the measure of angle E and angle F, which is here. Because then we can add the two measures together to find the measure of W, which is the whole thing out here. Okay, so angle E plus angle F will equal the whole thing. Two parts form a whole. So why did we do this auxiliary line? Because we form one of these lines up here. So this is a parallel line, this is a parallel line, and if you draw an auxiliary line that is parallel to the other two, then we go through where the line turns, the segment turns in between, then we if we continue these, let me do that, let me do it in blue. Yeah, that's fine. Oops. Oops. try this. Blue. All right, so if I start here and extend that, trying to get this as close as possible for my explanation. All right, so there's one, and if I extend this one the same way, all righty, let's try this again. I keep forgetting to do this. And let's use green. Okay, see what I just did there? I extended these lines. All right, so did I need to do that? I don't know. Maybe, maybe not. But if I focus on this, now this might make it confusing, so never mind. Disregard. It may be useful in other applications, but not here, so let's just go with this. This right here and this right here. These are two parallel lines. What I want to do is extend this. Yeah, I guess I could have left those. So if you extend that, that's your transversal. So this is parallel to my auxiliary line because my auxiliary line is parallel to both. So this is 41 degrees. What kind of angles are these if this is my new parallel line? Well, they're alternate interior angles, and we know by this, number 3, alternate interior angles are congruent. So if that's 41, the measure of angle E equals 41 degrees because alternate interior angles are congruent. Okay. Then, likewise, if this is my parallel line to this, this is my transversal. Got it? This is an alternate interior to F. So since alternate interior angles are congruent, the measure of angle F equals 35 degrees because of this. Now I can solve this. The measure of angle E plus the measure of angle F equals the measure of angle W. The measure of angle E is 41 degrees. The measure of angle F is 35 degrees. Therefore, the measure of angle W is the sum of those. 5 plus 1 is 6. 4 plus 3 is 7. So the measure of angle W is 76 degrees. All right, page 3, exercises. You know what that means. Exercise your brain. Pause the video. See if you can do these. Come back, check the answers. Okay, here we go. All right. We good? All right, measure of angle A. Well, this is corresponding, congruent, both acute, has to be 53 degrees. Measure of angle B, vertical to angle A, also acute, must be 53 degrees. So as I stated prior, when we have two parallel lines and a transversal, there are going to be two angle measures, and that is it. Unless the transversal is perpendicular, and then you only have one angle measure, 90, 90, 90, 90. All right? So the answer is either going to be the angle that gets given or its supplement. So the measure of angle C is a linear pair to this 53, or it's a same side interior to A. So it's 180 minus 53, just to do this quickly. 10 minus 3 is 7. 7 minus 5 is 2. So that is 127 degrees. When you have two parallel lines and a transversal, you will get two answers. There's only two angle measures for the whole thing. Unless they're perpendicular, then there's only one. Okay, so parallel, parallel, transversal, alternate interior angles are congruent. So this is 35 degrees. We have a, ooh, that was bad. Let's just not cut corners here. And then we have this straight line. So D and this angle here are linear pairs. Learn the terminology too. So linear pairs are supplementary. So the shortcut is just subtracting from 180, which I'll do now. 7 minus 3 is 4, and then bring down the 1. 145 degrees. Okie dokie. Alrighty. Moving along. Number 3. Alright. 2 parallel lines. Be careful though, we have 2 transversals. Okay? So you can't say that this angle and this angle correspond. They're not the parallel lines, so be careful. This is a trick. So 54 here, this is, E is 54, because this is my transversal. So it's always a good idea to label your transversal. So let's do that. So here's my transversal. So to answer this first question, the measure angle E, focus on the transversal with respect to the parallel lines. Okay, and what kind of angle is E to 54? Alternate interior. They're both acute, they're congruent. The measure of angle E is 54 degrees. Moving to the other transversal. How does it expect me to draw a segment when the command bar is in the way? All right, there we go. So there's my transversal. Switch back to my pen. What angle is this and this? Well, these two angles across from each other are vertical, so that's 112 degrees. And now I have same side interior, which are supplementary. So 180 minus 112, 10 minus 2 is 8, 7 minus 1 is 6. The measure of angle F is 68 degrees. All right, I'm going to give reasons. I'm going to go back to one, measure angle A. If parallel lines are cut by a transversal and corresponding angles are equal in measure. Okay, corresponding angles. Okay, and this one, B was vertical to A, and we found A above, so vertical angles are equal in measure. For the measure of angle C, it says if parallel lines are cut by a transversal, then interior angles on the same side are supplementary, same side interior. For the measure of angle D to be 145 degrees right here, it's because linear pairs form supplementary angles. If parallel lines are cut by a transversal, then alternate interior angles are equal in measure. So it's telling everything here. First we have to find alternate interior angles and then do the linear pair. And then number 3 I just did. For the measure of angle E, if parallel lines are cut by a transversal, then alternate interior angles are equal in measure. For measure of angle F to be 68 degrees, we would say vertical angles are equal in measure. Okay, we did the 112, 112. And then if parallel lines are cut by a transversal, then the interior angles on the same side are supplementary, same side interior. Okay, should have done that right from the start, but let's keep going. Now number 4. Wow, look at this thing. This might take some thinking. All right, so this might need, yeah, what was that term called? Anybody remember? Auxiliary line, yes, we need an auxiliary line. So let's draw that auxiliary line through here. All right, there's my auxiliary line. Let's assume it's parallel, it doesn't quite look it. Let's fix it. Auxiliary line. So let's focus on one of the transversals, if we will. So if, let me make it parallel and then I'll move it. Okay, so there we have it. Here's a parallel line, here's a parallel line. So we don't know what H is, but we have interior, same side interior angles. They are supplementary, so I would say, why am I down here? Oh, I'm doing 5 first. Okay, so we would say this angle here plus this angle here are same side interior angles, so they're supplementary, so 180, oh how cool, minus 162 equals 10 minus 2 is 8, 8 minus 6 is 2, so let's fix this, 20 28. Where am I going? All right, this is H. It's 28 degrees. No, it's not. This piece of H is 28 degrees. So let's just keep this over here. We got 28 degrees on that part. Now let me erase this. And now I need this piece of H. So now I'm going to take my transversal and focus on the other one. Okay. Let's make it look parallel and then move it. All right, so here's our line. And now I have this parallel line and my auxiliary line parallel. So these are same side interior, so they are supplementary because one's obtuse and one is acute. So 180 minus 98 is 10 minus 8 is 2, and 17 minus 9 is 8. So then we take the two angles, they add up to the whole thing. So this was 28 degrees. This piece was 82 degrees. So therefore the whole thing is 110 degrees. Did I do that right? No, I made a mistake right here. 162 to 180 is not 28 degrees, it's only 18. Oh, the humanity. All right, so that's 100 degrees. The measure of angle H, and I drew 110 again. 100 degrees. Okay, now that's better. All right, so if parallel lines are cut by a transversal, then interior angles on the same side are supplementary. Okay, so they're talking about the transversal being our auxiliary line. Same side interior supplementary, same side interior supplementary. Okay? All right, we're going to do the same number 4. We're going to go back up to number 4 now. And I'm just going to use the same transversals and auxiliary lines. So there's my auxiliary line. Move this up here. Rotate it so it's parallel. And put it here. So it's close, not close enough. All right, there we go. So we have, let's erase the last problem, get it out of my way. All right, parallel line. Looking at the auxiliary parallel line, this angle here and this angle here are same side interior, they're supplementary. So just a quick shortcut, 180 minus the given angle will give us the supplementary angle to that. 7, 10, minus 4 is 6, 7 minus 4 is 3. All right, so 1/2 of G, I shouldn't say half because it's not, we don't know if they're the same size. 1 part of G is 36 degrees. All right, now let's switch to purple. And now I'm going to move my transversal to the other transversal with respect to my parallel line and my auxiliary line. Now I have alternate interior angles. Be careful there. Those are congruent. That's 56 degrees. Add the two. 6 plus 6 is 12. 5 plus 3 is 8. Plus 1 is 9. The measure of angle G is 92 degrees. Reason? Vertical angles are equal in measure if parallel lines are cut by a transversal, then interior angles on the same side are supplementary. Okay. That only worked for one. It also should say alternate interior angles are congruent. Okie dokie. All right, number 6. Okay. For starters on this one, what we can do is, this is a line totaling 180 degrees, correct? So if I take 180 minus 117, I get its linear pair. 8, 7, 10, 3, 7 minus 1 is 6. So this piece is 63 degrees. Okay? 180 minus 129. 10 minus 9 is 1. 7 minus 2 is 5. So this piece here is 51 degrees. This angle here. All right. Bring down my, what's that called? Auxiliary line. And now let's get my arithmetic out of the way. Okay. So this is a transversal right here, right? So this angle and this angle, let me draw that with a segment better. This is sometimes hard to understand if you don't see it clearly. I'll use a thinner line too. So if we're talking about this, all right, straight line, that's my transversal. Here's my parallel line with my parallel auxiliary line. So these two lines are parallel. So if I drew this a little bit bigger, I have one parallel line, I have another parallel line, I have a transversal going through it. I know this is 51 degrees. And the other thing I'm looking at is the piece here. Alternate exterior angles are congruent. Okay. All right. We're trying to find the whole thing. So that's 51, this piece. Now I need to find this piece, and we have the answer. In order to do that, if I move my transversal this way now, and focus on this transversal, okay. Now what we have, let me get rid of my big diagram here. Okay, so let's blow this up. Now we're talking about this line up here, which is this one. My other, I don't want to do a dash. My other parallel line with my transversal coming through this way. I know this is 63 degrees, so this is 63 degrees. Well, where is that this? Right here. 63. Uh-oh, we have a problem. They aren't the same. What did I do wrong? Let's look at this again. The diagram's kind of small. Let me enlarge it. Okay, I made this larger so we can see it better. These are linear pairs, so 180 minus 129, 10 minus 9, 1, 7 minus 2, 5. This is 51 degrees. Okay, up here, 180 minus 117, 10 minus 7, 3, 7 minus 1, 6. That is 63 degrees. Okay, if this is 51 degrees, this is a transversal. So if this is 51, this is 51. If this is 63, this is 63. And so then I can do, this is 117. So therefore this is 63. So I don't want to clutter this up too much, but we have a triangle, and we now have 63 degrees here. Okay, almost there. So I'm going to use this triangle, and we know that a triangle sum is 180. So if I have 63 degrees for this angle here and 51 degrees for this angle here for 114 degrees for those two, then I subtract them from 180. I find my third angle. 10 minus 4 is 6. 7 minus 1 is 6. So this is 60 degrees right here. And it is on this red line, and this I over here that we're trying to find, so I didn't need a, actually, yes I did, never mind. All right, so 66 degrees here, this must be 114 degrees. Okay. So the measure of angle I is 114 degrees. Why? All right, let's recap this. This one was a little tricky. Linear pairs, 51. Linear pairs, 63. And what did I do? I added up those two and then subtracted from 180. But 63 plus 51 is 114. So I'm leading up to something here. All right? So if you're given this scenario, you're going to take the supplement to this and the supplement to this and add them, and you're done. Okay, so linear pairs form supplementary angles if parallel lines are cut by a transversal and alternate interior angles are equal in measure. All right, but I'm showing you a shortcut in this scenario. If you have this diagram and they're common, you take the supplements of both. So 180 minus 117, that gave us 63 degrees. Take 180 minus 129, and that gave us 61 degrees. Is that right? Yeah, that's 124, not 114. 180, 10 minus 7, 3, 7 minus 1 is 6, 10, 7, oh, that's a 5, that's why, hello. That's a 5. So that's 7 minus 2, because I borrowed from the 10s to the 1s. So 63 plus 51 is 114, okay? Take the supplement of this plus the supplement of that, and that would be the whole thing if you see this type of diagram. Okay, page 4 brings us to more exercises. So exercise 7, I've drawn the parallel lines green and the transversal red to focus on J. So this and this are what? They're in between the parallel lines, they're opposite sides. Alternate interior angles are congruent. The measure of angle J, 92 degrees. Now I'm going to take my transversal and focus on the other transversal. So now this is going to be my transversal. Now look at how that pops out at you. The measure of angle M and the measure of angle 46 are congruent because they're alternate interior angles, so M is 46 degrees. All right. And then, actually, if I left this back here for K, like this, and let me get rid of some of my marks now. Now I focus on, let's see, this and this are same side interior, so they add up to 180, so I'd say K plus, or the measure of angle, no, I'm not going to call it measure of angle K, I'm just going to say K. Alright, save time. K plus 92 plus 46 equals 180. Combine like terms. K plus 6 plus 2 is 8, 9 plus 4 is 13, equals 180. Subtract 138 from both sides, and K equals 10 minus 8 is 2, 7 minus 3 is 4. 42 degrees. The reason for 92 is if parallel lines are cut by a transversal, then alternate interior angles are equal in measure. Okay, for 42 degrees, this says consecutive adjacent angles on a line sum to 180. So what I could have also done is put 92 over here, 92 plus k plus 46 that way. All right, I did same side interior, so sometimes there's more than one way to do a problem. But if we use j plus k plus 46 is what they're saying, and we already found j to be 92, so it's the same equation as this. And then finally, the measure of angle M equals 46 degrees because if parallel lines are cut by a transversal and alternate interior angles are equal in measure. Okay, so now let's move on to number 8. I'm going to take what I have up here and mark my parallels with these greens. And I'm going to use the red one. Let's delete those. I'm going to use this red one as my transversal. Okay. So if I do this way first, I just like to label everything up. It's good practice. It may not answer the question, but it's good practice. So I'm going to do, these are alternate interior angles, so this is 37 degrees. Okay. These are linear pairs, so then I can find that. Or I can move this over like so and focus on this transversal and say alternate interior angles are congruent. So this is 44 degrees. Okay, and there's a couple ways to do this. So now we have a triangle right here, and we know there's 180 degrees in a triangle sum theorem. So if we take 44 plus 37 and subtract it from 180, we get this angle, and then do its linear pair. So I'll do that. 37 degrees plus 44 degrees plus n, no, not n, just call it x, equals 180 degrees. Okay, move that over here so I had room. So then 37 plus 44, 7 plus 4 is 11, 4 plus 3 is 7, plus that carried 1 is 81, plus x equals 180. Subtract 81, and we get x equals 99. So this is 99 degrees. Triangle sum theorem. This is a linear pair, so now n plus 99 equals 180. Subtract 99, and we get 81, which is up here actually. So that's 81 degrees. And remember that trick I told you. So if you see this diagram like so, and come here. If you see this diagram, parallel, parallel, and then two transversals meeting at a point, all you do is take the sum of these, 37 plus 44, and that is what? 81. All right. The reason we can use here is if parallel lines are cut by a transversal and corresponding angles are equal in measure. Okay. Number 9. All right, what's going on here? We have several parallels, so let's start by labeling this up. So if you have colored pencils, that's great. I have a lot of students who just mark these things all over the place. All right, so I'm going to do this and this. The one with the 1 mark are parallel, so I'll do those in green. And then the ones that are 2 marks are parallel. So this is parallel to this. Okay, so the reds are parallel, the greens are parallel, and my transversal is right here now. So, this is 94 degrees. It's going from my transversal to the green, from my transversal to the green. Same side of the transversal, both obtuse, both on the left side of my green parallel lines. They are corresponding angles, so Q is 94 degrees. This angle here and this angle here are corresponding, so this is 68 degrees. So once I find those, then this is a straight line, so then I get the equation. I'll move it over here. 94 plus P plus 68 equals a linear, I can't call it linear pair. Adjacent angles on a line are supplementary. 8 plus 4, so I'm going to say P plus 8 plus 4 is 12, carry the 1. 9 plus 6 is 15, plus that 1 is 16, equals 180. Subtract 162 from both sides, and we find P to be 18 degrees. Okay, so here are my reasons. So for P, consecutive adjacent angles on a line sum up to 180. The measure angle Q, if parallel lines are cut by a transversal and corresponding angles are equal in measure. That was for finding Q and this unknown over here, actually. But either way. Okay, so the measure of angle R in this case. So we have 130 degrees. So where are our parallel lines? First, I'm going to label those. I'll use these again. So there's one line. Okay, it's snapping. It's not quite straight. Maybe I can move this one. No, doesn't matter. Close enough. Okay, so there's my 2 parallel lines. Let me extend them. Beyond the diagram. Okay. So what do we know about this? It looks similar to one we did on the prior page, or even this one right here, actually. So N equaled this angle plus this angle. Not 7 plus 4 is 11, 4, 5, 6, 7, 8. So if this angle here is 96, then it equals this angle plus this angle. So finding this angle, it's 50 degrees because linear pairs are supplementary. So what do I add to 50 to get 96? And the answer is 46. Okay, so it asked what R was, and R is 46 degrees. Reason, if parallel lines are cut by a transversal, then interior angles on the same side are supplementary. If parallel lines are cut by a transversal, then alternate interior angles are equal in measure. Okay, so they extended this transversal and they did a whole bunch of work, but I'm showing you a shortcut. Linear pairs to get this one, and then this angle plus this angle equals that angle. All because it forms all those triangles, okay? All right, so relevant vocabulary are alternate interior angles and corresponding angles. Read those, review them, learn them, know them, love them. Page 5 brings us to the end of lesson 7. Go to your problem set.